Hello everyone, my name is Shambhavi. Hope you all are doing well. So into the previous video, we had watched out a question for the topics which we have discussed, right? So now basically in today's video, we are going to see two topics in this particular video. First, let me remove this lining which I had actually made out. And let me take out the colors from here so that we can start writing as well. Okay, fine. So what we are going to discuss, first of all, we are going to discuss regarding the comparison of two independent population means with known population standard deviation. Now this is a case when the two independent population means are there. We need to compare them. But what is my condition that applies? My condition applies that it should have known population standard deviation. This is my condition which is actually applying out here, right? So we are going to discuss this particular thing today, and as soon as we proceed on, I will let you know the second topic as well, which we are going to discuss right here. Okay, so let's get started. Okay, so let me put on the topic here. So my topic for today's discussion is comparison. Okay, that is not comparison, that is comparing. Okay, it's comparing two independent population means with it's like this, with known population standard deviations. Okay, so this is the topic for discussion of today. Right, so in this basically we are going to see out one of the formulas that is actually right here, which we'll be discussing out. Okay, there is nothing too much regarding the formula here into this particular topic actually. Okay, so let me just take out a color here, that are some different colors, so that we can proceed on with writing. And let's go. So okay, now just let me let you know something. The sampling distribution for the difference between the means is normal and both the population must be normal. It is a condition which applies that the sampling distribution for the difference between the means is normal, okay, and the population must be normal. Both the populations which are there, that must be normal actually, right? Now after that basically we are having the random variable, right? That was x1 bar minus x2 bar, which we had already seen into the previous video. Remember that we had already seen out some of the formulas, and there it was mentioned regarding some x1 bar minus x2 bar, right? So that normal distribution basically has a format, so that format we are gonna see here. So I would just write here normal, okay, not like this. So here goes the normal and comes the distribution, normal distribution. Okay, so it's like this, normal distribution. Now what's the formula which is basically into this? So the formula is x1 bar minus x2 bar, which I just told you that what is that? That is a random variable, okay, which is approximately equal to capital N. Okay, then here goes the mu1 minus. Okay, so basically now here we are having u1, not mu1, just 1 second, that is right here, minus u2, comma, then we have under root of sigma 1 square upon n1 plus sigma 2 square upon n2, right? So these are some things which we are actually having right here. Okay, now into this particular, what is the standard deviation? This was a normal distribution, right? Into this I would just write the standard deviation is. Now we'll be discussing about the standard deviation, that what is the standard deviation, which is right here. So that is around under root of sigma 1 square upon n1 plus sigma 2 square upon n2. Okay, so this is the standard deviation which we actually have here, right? So that is under root of sigma 1 square by n1 and plus sigma 2 square by n2. This is the standard deviation, okay? After that we have the test statistic, into the bracket, that's actually the z-score. So the z-score, right? Now this as well we are having. So into this, okay, Now what I would just do, I would just write z is equal to, the formula for this particular one is basically x1 bar minus x2 bar. Putting out the bracket minus, then we have mu1 minus mu2, right? And all of the things would be actually divided by under root of sigma 1 upon n1. The sigma 1 is square upon n1 plus then we have sigma 2 is square upon n2, right? Fine. So these are the sigma 1 and the sigma 2 values which we will be having into this particular z-score formula. So the test statistic that we actually call as z-score as well, right? We have discussed this thing already into the previous video, right? So that I'm just writing out here the formula, that is x1 bar minus x2 bar. That would be in bracket subtracted by bracket mu1 minus mu2 under root of divided by under root of sigma 1 squared by n1 plus sigma 2 is squared by n2. Right, this is out. So there is nothing too much into this particular topic, that is comparing two independent population means with unknown population standard deviation. Okay, these only were the formulas which I wanted to let you know. Now, after this, as I mentioned, that we'll be discussing the second topic as well into this particular video only. So now let's discuss out that second topic that I was about to discuss. So that name of the particular topic is comparing two independent, so here goes the independent population proportions. Okay, this is basically the next one which we are going to discuss today. That is basically the comparing two independent population proportions, right? Okay, now okay, let me just write out some things here first of all. Why these slash are coming, let me come down. Fine, let me write out the first point here. Let's say that is here. Fine, so I would just write that the two independent samples, the two independent samples, so samples, the two independent samples are simple random samples, are simple random samples that are independent. So that are independent. So what do we mean by two independent samples? The two independent samples means that these are the random samples that are actually independent. Okay. Second point regarding this is the number of successes. The number of successes is at least 5, and the number of successes is at least 5, and the number of failure is at least 5 for each of the samples. Now this is one another thing that comes, that number of successes is at least 5, and even the number of failure is as well at least 5 for each of the samples. Fine. Now next thing regarding this. Now next thing I would just write here, comparing two proportions. Comparing two proportions, like comparing two means, is common. Basically, whenever we just say about comparing of the two proportions, let's say I just take an example that I would compare two means. So yeah, that is a very common thing that actually occurs, right? If basically two estimated proportions are different, then it can be this particular thing can be because of the difference in the population, or it can be due to the chance, right? The two conditions can be actually applied if two estimated proportions are different. First one, it can be due to the difference in the population, and the second one, that it basically can be due to the chance. Right. So now basically a hypothesis test is the one which helps in determine the estimated proportion. Let me write out this important thing, that the hypothesis test can help determine, okay, the hypothesis test can help determine proportions, determine in sorry determine, okay, can be, it help determine if basically if a difference in the estimated proportions. Here goes the proportions. Okay, yes, the hypothesis test can be determined if a difference in the estimated proportions PA, that is noted by PA minus PB. Okay, so PA minus PB reflects a difference in the population proportion. Right, so the hypothesis test can actually help you to determine a difference in the estimated proportions PA minus PB, which reflects a difference in the population proportion. Right. Now, this difference basically, or this difference of the two proportions actually follow out an approximate normal distribution. Okay. Now, generally, what does the null hypothesis test tells us? So, null hypothesis basically states that the two proportions are the same. Right? It basically tells us that the two proportions are the same. Right? That is basically H naught. Okay, it is basically, we just wrote it like this, right? The H naught, or you could just H0 as well. So that is PA is equal to PB. We used to write it like this, right? And P was a small after, not capital. Right? We used to write out the null hypothesis like this because we had already discussed this thing in the previous videos. So basically, to conduct out this test, we basically use out a proportion, that is P. Right? Hope you just got the idea regarding this thing. So that is PC. Actually, to conduct out this, we just actually in the terms of like this thing, we just call it as pooled proportion. POOLED, pooled proportion. Okay. So this pooled proportion is basically calculated by the P, like the denotation which we give it is actually PC. Capital P and then small p, and then in the denominator it's C. So it's like okay, let me remove out this thing. It's P and here it's C. Okay, this P is actually small. So it's small p and here goes the C. Right, this is actually how we just denote out this pooled proportion. So hope you just got out the idea regarding this particular thing. Now there are several formulas as well into this, but we are not just going to discuss this right here. We'll be discussing into the next video. So we saw that comparison between the two independent population means with the known population standard deviations, and even we see the comparison of two independent population proportions. Right. Hope you just got the idea regarding all of these things which I told you regarding the formulas and regarding some theoretical things which I just mentioned. Right. So this is all for this video. Till then, thank you and take care.